Alright, in this lesson, we'll discuss the exponential definitions and we will use them in conjunction with exponential laws. The first one that I want us to look at is a base raised to the power of 0. Right, any base raised to the power of 0 is 1. Please take note of that. Like these are examples here. Any base raised to the power of 0 is 1. And then x to the power negative a. This is the same as x to the power negative a over 1. When we move the power from being the numerator to the denominator, the sign of the exponent changes. So x to the power negative a, if it moves down to become the denominator, it becomes 1 over x to the power a. Even here, x to the power negative a, if it's moved upwards to become the numerator, it becomes x to the power a. So when a power is moved upwards to become the numerator, the sign of the exponent changes. It's the same principle here. This one moves downwards, becomes x to the power a. And then this one, y to the power negative a, moves upwards, it becomes y to the power a. Okay, so we can simply use these definitions when simplifying exponential expressions. Let's start with the first one, a. We have 8 to the power negative 1 over 3 plus 100 to the power 0. 8 written as a product of its prime factors is 2 to the power 3 raised to the power negative 1 over 3, and then plus 100 to the power 0 is 1. Any base raised to the power of 0 is 1, using this definition here. So that is 1. And then here, raising a power to a power, we multiply the exponents. 3 times negative 1 over 3, that's negative 1. So this is 2 to the power negative 1 plus 1. But we are asked to write our answers with positive exponents. Using this definition, we can say this one is 1 over 2 to the power 1 plus 1. Then 1 over 2 to the power 1 is 1 over 2. Then 1 over 2 plus 1 is 1 and a half. Then that is a. Let's do b. 1, and then a to the power negative 2, then b to the power 3. Right, so this power with a negative exponent can be moved upwards to become the numerator. When it moves upwards, the sign of the exponent changes. So it becomes a to the power 2 over b to the power 3. This one remains as the denominator. Right, c, 81 over x to the power negative 4 to the power 3 over 4. Right, 81 is 3 to the power 4 when written as a product of its prime factors, and then x to the power negative 4, right, to the power 3 over 4. This is a power of a quotient. So we distribute the outside exponent. It becomes 3 to the power 4 times 3 over 4 over x to the power negative 4 times 3 over 4. Right, and then 4 divided by 4 is 1. We remain with 3 plus 3 cubed over x to the power negative 4 divided by 4 is negative 1. So we remain with negative 1 times 3, which is negative 3. This power can move upwards to join the numerator there. It becomes what? It becomes 3 cubed x to the power 3, which is 27 x to the power 3. D 0,008 to the power negative 2 over 3. 0,008 is like 8 over 1000. Okay, to the power negative 2 over 3. And then 8 is like 2 to the power 3. And then 1000 is 10 to the power 3. Right, all this to the power negative 2 over 3. Right, this is a power of a quotient. So you can say 2 to the power 3 times negative 2 over 3 over 10 to the power 3 times negative 2 over 3. And then what do you get? 3 divided by 3 is 1, will remain negative 2. So it's 2 to the power negative 2 over 10 to the power 3 divided by 3 is 1, negative 2. So we can use this law here. So this is equal to, this one goes up, becomes 10 to the power 2, and this one goes down, becomes 2 to the power 2. So which is 100 over 4, which is 25. E 4x cubed over 6x to the power negative 1. We can simplify the coefficients here. Divide by 2, we get 3. Divide by 2, we get 2. There are two ways we can simplify this. We remain 2x cubed, then 3x to the power negative 1. Okay, let's start by moving this power. So it goes up, becomes 2x cubed times x to the power 1 over 3. Then becomes 2x to the power 4. Multiplying powers at the same base, we add the exponents. Okay, that's the answer there, right? So the other way you could have done it using the quotient law. When dividing powers with the same base, we subtract the exponent. So it's 2, then 3 here, and then say x, then 3 minus negative 1. Remember the quotient law. And then becomes 2, then x, 3 minus negative 1, that is 3 plus 1. You're getting that. So it's the same thing.